Hey, what's up everybody? Mr. Smith here. In this video, we're going to talk about something called completing the square. So this is a method of solving quadratics that we're going to talk about in this class. We've talked about a couple already. We've done factoring. We've talked about solving by square roots. And now today in this video, we're going to talk about completing the square. All right, so these are just a few of the methods that we've done so far. And we're going to talk about completing the square in this video. So what does it mean to complete the square? Well, first off, we got to talk about what it means to be a perfect square, particularly a perfect square trinomial. What does that mean? Okay. All it means when you're talking about a perfect square trinomial, if you ever hear me say that, that is something that factors really easily. That's all that is. So example would be like x squared plus 2x plus 1. And when I say it factors really easily, I mean in particular it has repeated factors. Okay, so if you wanted to factor this thing, you do a times c, 1 times 1 is 1. You need two numbers that multiply to 1 and add to 2. And if you think about it, it's just 1 and 1. So you could factor this to be x plus 1 times x plus 1. What I mean is that they have repeated factors. That's what a perfect square trinomial has. The two factors are going to be the same, and it's pretty easy to find. Okay. First, we got to be able to tell how to turn something into a perfect square trinomial. There's an equation that we use to do this. This process is called completing the square. The equation that we use is, it looks like this, b over 2 squared. Okay. So in this example here, if I said, what do I need to do to complete the square in this equation? Or, in other words, make this thing into a perfect square trinomial that can be factored really easily. Well, all we got to do is use this equation right here, b over 2 squared. I've got a, I've got b. I don't really have a c term yet, but I'm going to find it. So I'm going to do b over 2. b is 8. So that's 8 over 2 squared. Well, 8 over 2 is 4. Remember, we do parentheses first. And 4 squared is 16. So that means 16 is my value that will complete the square here. Okay. So now let's think about this new equation. X squared plus 8x plus 16. Let's say you want to factor that. Well, a times c, 1 times 16 is 16. If you want to factor this, you need two numbers that multiply to 16 and add to 8. And if you think about it, it's just 4 and 4. So that would factor to be x plus 4 times x plus 4. So now it factors really easily. It has repeated factors. It's perfect square. Okay. We got that number by using this equation, b over 2 squared. Let's do one more example before we move on. If I want to turn this into a perfect square trinomial, again, I'm gonna a term. I got my b term. I'm going to use b over 2 squared. b is negative 18. So it's negative 18 over 2 squared. Negative 18 over 2 is negative 9. And negative 9 squared is positive 81. So that means my value to turn this into a perfect square is positive 81. Okay. So this equation is going to be important for us. We're going to use it a lot when we complete the square. So let me show you how we're actually going to use this to solve a quadratic. All right. Why do we need this thing? Why do we use it? How is it going to be helpful for us? So let's say that we're trying to solve this equation, x squared minus 10x plus 36. Remember, so far we know how to factor, and we know how to solve using square roots. Those are the two methods that we have so far. If you try to factor this thing, you would need two numbers that multiply to 36 and add to negative 10, and you would quickly find out that you can't do that. So factoring is not going to work. This thing is not factorable. So factoring is not going to work for us. Try to solve using square roots. Well, you've got an x squared, but you also have another x running around. And you have no way of combining those. Okay, so we can't solve by square roots either. So that means none of the methods that we have so far work. So we have to use completing the square. Okay, completing the square is pretty much always going to work for us. It's kind of a last-ditch effort when we don't have anything else to, when we can't factor, we can't use square roots. We can always use completing the square. So I'm going to walk you through this process. Follow along with me. It's kind of a long process, but I'm going to try to break it down and make it simple. So in order to complete the square, we are going to use we're going to complete the square to solve this equation since we can't factor or use square roots. First, what we're going to do is get all of the x's on the same side of the equation. So I'll have to subtract 36. They're already on the same side of the equation, but I mean get them all alone. So it's going to be x squared minus 10x equals negative 36. Okay. So we got the 36 over here. Now I just have x's on the left side of the equation. So now what we're going to do is we're going to do the completing the square thing. So I'm going to use that equation, b over 2 squared. Well, b is negative 10, okay? So that is going to be negative 10 over 2 squared, which is negative 5 squared, which is positive 25. All right, so that means the value that completes the square here is positive 25. And what I'm going to do is add this number, 25, to both sides of the equation. So I'm going to add it to the left side of the equation to turn this thing into a perfect square. But whatever I add to one side, I also need to add to the other. Okay? All right, so we can simplify this real quick. X squared minus 10x plus 25 equals negative 36 plus 25 is negative 11. Use a calculator if you need to. Okay, so the reason that I added this 25, the reason that I went and did this and added it to this side of the equation is because now what's on the left side is a perfect square trinomial, meaning it factors really, really, really easily. So now I'm going to go ahead and try to factor this thing on the left side. If we factor this, right, the leading coefficient is 1. So if you do a times c, it's just going to be 25. You need two numbers that multiply to 25 and add to negative 10. Well, if you think about it, you could do 5 and 5 or negative 5 and 5, and that would work for us, right? So it's going to be x minus 5 times x minus 5. That equals negative 11. And so I just factored that thing on the left to be x minus 5 times x minus 5. And that was the whole point that I did completing the square, is so that I could factor this thing easily. That was the whole reason we did the completing the square step. So now I'm going to make a little jump here. X minus 5 times x minus 5, that's just something times itself. So we can rewrite that as x minus 5 squared. All right? So x minus 5 times x minus 5, you can write that as x minus 5 squared. Now, this looks like something we can solve using square roots, right? I've got the thing being squared all by itself, so I'm going to take a square root of both sides. It gets me x minus 5 equals plus or minus. Can't forget about that unless you want Mr. Smith to have an existential breakdown. Don't forget about your plus minus. The square root of negative 11. Okay? Now we're almost done. We're almost done. Trying to get x alone, so let's add 5 to both sides. All right, remember we said plus and minus always goes in the middle, so it's 5 plus or minus the square root of negative 11. And there's one more thing to do here to simplify. I've got a negative sign underneath the radical, which is a big no-no. We don't like that. That's a one-way ticket to Calcatraz, math jail. So if you got a negative sign underneath the square roots, you got to pop that out to the front. It's going to become 5 plus or minus I times the square root of 11. Okay. And now there's nothing else we can do to simplify this. So this is going to be our final solution. All right. So again, let me walk you through what we did one more time. First, we got all of the x's alone on one side of the equation. After we did that, we came over here and did our completing the square, b over 2 squared formula, with b being negative 10. That gave us our value that turns this into a perfect square, so we added that to both sides of the equation. Okay, once it turned into a perfect square, we factored it, and that's the point. It factors really easily. And then we rewrote that as x minus 5 squared and just solved using a square root from then on. We had to simplify a little bit in the end. Okay? We're going to practice this a lot, all right? So if that process seemed really crazy to you, we are going to practice it, okay? So just try to get a gist of how it works right now. We'll practice it when you're back here in school. Let's do, okay, so this is a good thing to mention. Again, when you can't factor, or if you can't use square roots, that is when you use completing the square, okay? So if you try to factor first and it doesn't work, you can solve by completing the square. Let's do, I'm just going to get you started on this one. I'm not going to carry it all the way through for the sake of time. Let's say you wanted to solve this with completing the square. So remember, first, you need to get all the x's alone on one side. So I would need to bring this 12x to the other side. So I'd have x squared minus 12x equals negative 96. And then we could do our completing the square. So it would be b, which is negative 12. Remember, it's b over 2 squared. So that would be negative 12 over 2 squared. That's negative 6 squared, which is 36. So then I take that number and I add it to both sides of the equation. X squared minus 12x plus 36 equals negative 96 plus 36. Okay. And then from here, I'm not going to carry it out just for sake of time. You would factor this thing, okay? It would factor really easily. It'd be x minus 6 times x minus 6. All right, and negative 96 plus negative 36 would be negative 60. Okay, and then you would just finish this out the same way we did on the other one. The reason I wanted to show you this is because if everything is kind of out of place in the beginning, we still want to get all the x's on one side of the equation before we go and complete the square. All right, one last thing in this video. Completing the square only works when a is 1. So it only works when our leading coefficient is 1. So notice how in all these examples, my leading coefficient in front of the x squared has been 1. That's the only time that it works, okay? So if you have one where the leading coefficient is not 1, like it is in this case, it's 2, well, that doesn't mean you can't use completing the square. You just have to divide everything by whatever this number is and force it to become 1. So what I mean by this is if I want this to become a 1, I'm going to divide everything by 2. So then 2x squared divided by 2 would be x squared. Negative 8x divided by 2 is negative 4x. And 28 divided by 2 is 14. And then from there, we could just go ahead and complete the square. Okay? So keep that in mind, it only works for a equals 1. All right, so remember, if it can't factor, if it can't use square roots, that is when you start thinking about completing the square. All right, so I'm trying to make this video a little bit shorter this time, so maybe you guys will watch them. We're going to practice this tomorrow if that seems really convoluted. So hopefully this just gave you a gist of how completing the square works. All right, let me know if you need anything, and I'll see you guys next time.